Hello everyone, hope you all are doing fine. So all my subscribers will get the notification for this new video. So post COVID, this is the new video I'm making this for HANA Architecture. I got a lot of requests for making other videos also on many other topics, and I'm going to do it soon one by one. So let's start with this video. So SAP HANA 2.0, as we know, is a multi-tenant database. By multi-tenant database, it means that in the single host or in a single instance, you can create more than one databases. That's what we call as a multi-tenant database. So here we have one system database. System database is the master database, like it has the complete control over all other databases, and it governs it. And then we have one master tenant database which gets created by default after you install HANA 2.0. And then further you can add as many tenants you want. So as for analogy, we are going to consider the structure of a building and the landlord and tenants as a explanation towards this MDC structure of HANA. So as you can see in the screen in the diagram, that the lowermost portion of the building, it's a two-story building. The ground floor, I've considered this as an operating system. Just do a assumption. Imagine in your brain that there's a building. The ground floor is the operating system on which the complete database is built. So both your tenant and system, both are on the same host, on the same operating system. That operating system governs the processes for both system as well as the tenant databases. Now, consider my system database. Consider this complete building which you see, where the ground floor is where you can consider as a operating system or the host on which this complete database is built. So this complete building is owned by a person, and that person is the landlord of this complete building. Now he rents out one of the flat or one of the floor in the complete apartment as a rent to a tenant. Now that is considered as a tenant database. So from this structure, we can easily define the MDC. So where it's completely owned by one database, which is system database, who acts as a landlord, and therefore we also have few tenants. Here we will consider in our example, in the other further steps, we are only going to consider the structure for only one system database. Sorry, if there's only one system database in all the SAP HANA system, there cannot be multiple landlords, but there can be multiple tenants under the same landlord. So we will be considering exactly the structure of one system database with one tenant database. So first is Scaleup. So we commonly hear this term in interviews and everywhere. What is Scaleup and what is Scaleout in HANA? And have you ever worked in Scaleup environment? Have you ever worked in Scaleout environment? So what is the basic difference? Another thing, and it becomes like very tricky to answer. But with this analogy, it becomes very clear in the image in our brain that how we can answer such kind of questions. So again, considering the same. So consider one single building, which is in the name of a person. He is the landlord of that complete building, and one of the floor he has rented out to someone, and he is residing there as a tenant. So this structure is called a scale up in HANA. Now suppose if he wants to rent out, or if someone comes to the landlord and says, hey, I need a rented flat, in your apartment. Can you do you have the space to rent it out for me? And then the landlord says, okay, you are going to pay me more. He says, yes. Then what he will do? He will add one more floor to the same apartment. He will build a new floor to the same apartment and he will again rent it out to a new person. So multiple tenants in the same structure or in the same building, vertically expanded, is our scale up system. Also, the scale up in HANA can also be considered if the already existing tenant tries to say that, yeah, the space which I am utilizing as of now is not sufficient for me and I would like to expand my living in the and I would like some more space. So the landlord tries, okay, you need more space. If you are ready to pay more, I am going to expand one more floor. So that vertical expansion where the already existing tenant wants to expand its resources, in that case also it's called the scale up. If everything is happening on the same host, all the expansion and all the addition happening on the same host, it is called scale up. Similar way, we can we will try to explain the scale out now in the similar way. So consider this scale out. Now in scale out landscape, we will consider two kind of structure. One is with multiple tenant. Now consider this same landlord cannot scale up his system because of the limited resources. Government has provision, no, you cannot build a house more than 2 story in this area. What you can do is you can parallelly build many houses in your name. So what he did is he has parallelly built 2 other houses. Now, as he has now multiple tenants staying in different other houses, but all houses, like suppose we have a tenant in house 1, then we have a tenant, 2 tenants in house 2, and then again we have 2 tenants in house 3. The ground floor of all is considered as an operating system because these tenants are residing over that and the operations are getting controlled by the operating system. Now, considering all these 3 houses, this all 3 houses are owned by a single landlord. That's what we call as a scale out. But it has multiple tenants and all the tenants are divided but governed by only one system database. That's what we call as a scale out. Now we will consider second scenario of scale out where one single tenant tries to expand its space in different other buildings. Now suppose we consider the first building where the operating system is marked in black and blue as a system database. So we see that there is one tenant which is tenant database one home. So the first tenant resides in this building. He goes to the landlord and say, "Hey, I'm not able to control my operations from within one floor or one part of the apartment. I need to expand it. Do you have different other place to rent it out?" The landlord says, "Yes, yeah," and then he rents it out. So how is it? It's like the other place where in the earliest part of the video where we saw that different other tenants were given those space in different other buildings under the same landlord. Now that same space is been provided to the same tenant, but the same tenant has divided his operations in this different buildings. So every building is a host. Now what he does is in the first host, he is using it as a home, like he is using for some part of the operation. In the second host he is using it for some other part of the operation. Suppose his office space he is utilizing it for doing some kind of stuff or anything, and then he has one space which he is using as a guest house. If someone comes in, he is asking them to stay over there. But for all this he has only one landlord, which is the system database. So this is the MDC structure. Now this was the analogy. Now let me explain you in the technical terms. What happens in the scale up environment? You have a system database, you have a tenant database on the same host. Now we have to expand multiple tenants. There is a requirement that we have to add one after the other tenants instead of adding one after the other schema for some kind of functional operations in the application. Then what we do is we expand it. We scale it vertically. So by scaling it vertically means one single host it was using earlier, suppose 6 to 12 cores of CPU and around like 256 GB RAM. I expanded it to use like 1 terabyte of RAM and around like 64 cores of CPU. In that situation, I can easily accommodate two more other tenants in the same host and use it. Now, what else? This is about the scale up. Now in the scale out. So scale out the first scenario which I spoke about. So first scenario, what happens? I have a requirement for again expanding the multiple tenants, but now I have a restriction. My hardware is not supporting more than that kind of RAM or the CPU. Or suppose I have a limited space in the data center and I want to take up another space where I want to expand it. So it is not expanding vertically but expanding horizontally. So I will build multiple hosts and then the system database will run on one host. The instance will be configured on one. But again, in the multiple host, I will install HANA and I will only create tenants there. So tenant creation, while creating the tenant, it gives you the privilege to assign which service or the tenant will run on which host, and you can easily divide the operations, or you can create multiple tenants on multiple hosts. Even that can happen. The second scenario of the scale out, where you have a system database running on one host and then the same tenant, there is only one tenant, and which where you want to scale out the operation. So or rather expand the operation, but you cannot use a scale up. In that case you want to use a scale out. So you again created multiple hosts and you expanded the services of the same tenant into multiple hosts so that it can be help you in getting it parallelly processed. Where do we use scale up and where do we use scale out? So scale up we use in such kind of environment where there is where suppose we have like one system database, one tenant database, the operations are restricted, and we we have to there are few jobs which runs on that tenant database and which are like kind of utilizing lot of resources, or there is a increase in the user base. So my users have increased from 1000 to 10,000. In that case I will go for a scale up. I will increase the resources in the same environment and I will allow them to use it. How is it in the scale out? So in the scale out, my user base is constant. My user base has not increased a lot, but my operations has increased. Now I have like around earlier I used to operate on 1000 tables. Now I am operating on 1 lakh tables. So in that case, I will go for a scale out. I will divide those tables into different hosts by doing partitioning and other. There are other technical things which we will cover in the later part of the other videos. The how do we do partitioning and how do we utilize, how do we do parallel processing on the things, how we can optimize the performance, everything on this will be covered on the HANA series of this video. So that's where you utilize the scale out property of HANA and you scale out your environment. Now let's talk about the services because this is the architecture video, so not going into depth into that, but let's talk about the services now. So we have the first one, which is the name server service. So name server service, what does it contain? It's like a secretary of your building. So your building has a chairman or secretary or suppose anyone who has the complete data. So he knows each and everything about your HANA database. That is what we call as it as a name server. It has each and every detail. It has the details in respect to the address, which port, where to assign, who is living where. Like where the tenant database is assigned. So he is like a secretary. He knows in which floor who is living, what they are paying, and everything. But the service is restricted. Like in a real life analogy, what we see, the landlord knows who is living in which apartment, which he has rented out. He has the details of the person who is living there, like where he's working or each and everything. But he doesn't have the detail of the data inside that, like what he is keeping in his house, whether he bought a new refrigerator or whether he bought a new microwave oven. He is not going to inform the landlord, neither is landlord going to question him, hey, what did you brought? Tell me the things which you have brought this month, or tell me your complete data. He is not going to provide it, neither he is going to ask for it. So that is user specific data or the tenant specific data. So tenant specific data is only with the tenant. That kind of information is not there with the name server. Name server only has the topology kind of information, who is residing where, how to connect to that person, or what is the contact information, and all these details. So that's what we call as a name server service. And name server service runs in the system database, because who is your landlord? System database. So obviously who will be having this information? System database itself. So name server service should run in the system database. Now we have a compile server service. Like for every building to run, we need a generator. Similarly, we have a compile server service which runs the complete HANA services. It's not that without that it cannot run. It's not that it is the main service to process everything, but it is a requirement like an electricity. So that's how we do an analogy for the compile server service. You might think of a better example after I explain this topic to you. If a better example comes in your mind, just do mention it in the comment. It will be like reverse learning for me, and I always prefer that. So where is the compile server runs? The compile server service is also a part of the system database. So system database or the landlord has to make sure that your building has the complete supply of electricity, and none of the tenants are complaining, hey, I'm not getting proper electricity supply here, I'm not able to run my services or do my stuff. So that's how the compile server service helps in maintaining the proper functionality of the your database. And what is the use of it? It contains, in the technical terms, it contains those few of the data, or those few of the metadata kind of tables and objects which it uses to compile each and every operation and helps in further processing. So that's what the compile server service do. Now next is our preprocessor. What is the preprocessor? Preprocessor is like a watchman. So any information comes to it, it keeps it with us, and or it passes it to the tenant only the required information on which the tenant needs. Like suppose if a person comes to the watchman and says, hey, I came from here, I came all the way through this, I took this cab, and then I paid this fare, and then I came here, but I came to meet this person because for one so reason. So he is going to the person, he will go to that tenant and he will inform, hey, this and this person has come to meet you, but uh, and this is why he wants to meet you. He is not going to tell him the complete story. Hey, this has come from here, how much he paid for the cab, and each and everything. So that's what this preprocessor service does. It's like a watchman. Not exactly it passes the information, but it keeps a track of the data, which is further utilized by the tenants. And this is a very important service because this is always used by the main service of the tenant, which is index server. So what is the index server service? Every tenant has a primary point of contact. Like in every family, there is a family head. In every house, there is a house head. Similarly, this is the index server service. What it does is It receives all the requests and it processes it. It is the one who is going to process. It is going to one who is going to tell each and every one in the tenant, whoever is residing in his premises, that hey, I received this, do this and this job, and then provide it back, the status. So that's what the index server service does. We will now see the complete analogy flow so that it will be like a very much understood how the things work. So suppose a request came through the door. The door is our HANA database. An application is trying to make a request or a person is trying to visit my tenant. Now, as soon as he comes to the door for the first time, he will go to the name server. He'll ask him, hey, I have come to meet and so person, or I have come to do a business with so person. You are the secretary of the society or the building. Could you please tell me more about him? He is going to provide the information about the tenant. Okay, this information that he is the tenant and he can, this is the way to his door and you can go and speak to him, and this is his details. You can keep his details so that later on again, whenever you need, you can contact him. So this kind of validation is provided by the name server. And what is important here is, you see in the diagram, it's the electricity, which is our compile server. Without compile server, the name server cannot compile the information and provide it to any request that where is the tenant or where is it exactly residing or any topological information. It cannot provide. None of the service in HANA works apart from daemon. So none of the service in HANA works apart from daemon service, which doesn't require compile. Now we will see the flow analogy. So first time the secretary of the society or the name server service has told where the tenant resides or the index server is. Now, the second time the request came, because the request is already registered now, the second time it came, it is not going to flow through the name server. If it has kept all the information and the direct request has been allowed to the tenant, if it is already registered and it has been registered, okay, the tenant resides in this port, you can directly connect to the SQL port of the index server and you can do all your processing. Then it will not go through the name server. It can directly go to the second door. Like he entered the premises, he went to the tenant's door, he knocked it out. Hey, I have come here for this request. Now the tenant when how the tenant will process the data. So the tenant needs this again this two tool to process the data, or the index server service and the tenant needs these two tools to process the data, or the two services to process the data, to be specific. One is your generator or the electricity, that is compile server. The other one is the preprocessor. The watchman, the index server or the tenant will speak to the watchman first. Hey, this data is there. What do I need to do about it? Then he will tell, hey, this guy has come up here. This is the data. And he's saying this and this. You work on this. That's how the complete processing is happening here. So what is important in HANA is none of the services are not considered as important. Whatever the services has been included in this video, which is our only main services like name server, then your index server, compile server, preprocessor server. So these all are main services. There are other services also like statistic server, which I have not included in this analogy because that is, I do not consider that as a very important service to run HANA. That is something to only provide the statistics and other details on HANA. The other thing is daemon service. So daemon service is something which controls the other services. Like if any service is not working properly, the daemon service will try to restart that service or try to get a connection to that service, that why it is not running, try to dump it out. Dump it out means try to find out the error and put it in the logs where you can further go and analyze it. So these kind of things are done by the daemon service. But processing wise, these are the few services which are responsible for the complete processing. So that's about the HANA analogy. If you have any questions, put it in the comment section. I will also be providing few links in the comment section. Do read the links mentioned in the video description, and that is going to like help you out in learning and understanding the HANA architecture in much more depth technically, which will help you qualify your interviews. This video is only for the analogy purpose so that you can connect it with a real-time example. You can understand the fact how it is going, how it is working, and it will always be in your mind. You will not be forgetting what does. Anytime you see a building, you see a watchman, you see a person, instantly the recap of this video will come into your mind. Hey, this is the our HANA MDC. That's how it works. You will start connecting to it. In this way, it helps you to understand and memorize. And at any point of time, someone questions you, the answers are on the like verge of your tongue, and you can easily say that. So that's the main motive behind this kind of analogies. And there are links in the description which so do check the links below in the description, and do like, subscribe and comment on my channel, and I'm open to advice and help you out. Thanks a lot.